Hello, my name is Sokolowski, and I'm going to demonstrate to you on the random word web page example how to use ProTI. To follow along this demonstration, you require installation of Node.js, npm, Pulumi, and if you also want to run the deployment, an installation of the AWS CLI, which has to be logged in into an AWS account with permissions for AWS S3 resources. To get started, I clone the repository of the demonstration, which you can find on this path on GitHub, and change into the directory. In this directory, you can see that it contains a very simple Pulumi TypeScript program, which is a static web page that shows one randomly selected word from this array. So what this program does is it creates a bucket. Then it draws a random integer to select a word from the array. It uses the selected number of that integer to then create the index web page. And in the content of this index web page, we actually set the randomly selected word from the words array. Below this comment, you find more resources. These resources are not further interesting for this tutorial, but they are needed to make this website actually publicly accessible on the internet. So to get actually started, you see Visual Studio Code is complaining here that the dependencies are missing. We first have to install the dependencies, and we can do so by running npm install. This installs now all our dependencies, which are defined in the package JSON. And you can see this is the Pulumi dependencies, and we have some additional development dependencies. And particularly, these are YEST, TS-YEST, and ProTI packages, which we need for the ProTI test runner. The dependencies are installed now, and we can now go ahead and try to deploy our program. To do so, I use Pulumi up. If I run the first time Pulumi up on a project, it asks me to create a new stack or to select an existing one. I'm going to create a new one and call it demo. And now Pulumi shows me a preview or generates a preview. It shows me which resources it wants to create, and I can confirm that with selecting yes. The website is now deployed, and we could open it in a web browser using this URL, and we would see that it shows one of these three words in uppercase. To undeploy this program, we can use Pulumi destroy. Again, here I have to select the stack. Pulumi shows me in the preview what it wants to delete, and I can confirm the selection with yes. I now select the stack such that I don't have to do that every time. Now I will run Pulumi up another time to see whether it can create the web page a second time. This time I use the skip preview flag and the Y flag to avoid the interactive dialogues. What we can see now that an error happened during the program execution. Precisely, Pulumi is complaining cannot read properties of undefined reading to uppercase in line 16. So if we have a look at line 16, we see that here we indeed call the function to uppercase on a value that we get from the words array. However, this value seems to be undefined. That is the case if either the value that was in the array is undefined, but we don't have an undefined value here, or if we have an index out of bound access. So that seems to be the case here. Seems like we had a word ID value that was not 0, 1, or 2. The word ID value is the post-deployment value of rng.result, the randomly drawn number from our random number generator. So it seems like that there's a problem with the configuration of this resource. And if you look at the configuration, which is RNG range, we see that we configured it to draw a random value from 0 to words.max length. We see that we configure it to draw a random value from 0 to words.length. And words.length is 3. So this is actually a bug. The correct version would be words.length -1. Okay, so this is a bug in the program. Let's undeploy it again and see whether we can find it with ProTI or whether ProTI finds it. To do so, we run ProTI, and as ProTI is a yes plugin, we just run yes by running npx yes. Okay, what we can see is there was a failed test, and that means ProTI found the bug. And the error message is exactly what we saw right now. So ProTI indeed found the bug that we just saw when we actually tried to deploy the program. Great. So let's apply our fix. We already found out what the fix is. And run ProTI again. Now, as the bug is fixed, we should not see that ProTI finds a bug anymore. However, that's not the case. ProTI still finds the bug. The problem we observe here is that actually our test generation plugin is too imprecise. Our test generation plugin generates for RNG results values of the type of random integer.result. And that type is number. So within the test cases, ProTI generates any number value for word ID. This is too wide. Actually, what we want is that it resembles the behavior of random integer and only generates random numbers from 0 to words length -1. However, this generator is too general and doesn't implement that. This may be the case for future better and more advanced generators, but right now this is not the case. So what we need to do, we need to narrow down this generator for this specific case. And we can do so using ProTI's inline specification syntax. And to do that, we first have to import that syntax by importing the entire ProTI IaC spec package. And using this package, we now can define that for this property, we want to generate, with ps generate, values with, and in this with, we now provide the fast check arbitrary to generate values with. We can do so in this case with ps.integer, because we want to generate integer values in the range defined by RNG range. So with minimum 0 and max words length -1. What we did here now does not change the behavior of the program for regular Pulumi executions. However, for tests with ProTI, it says generate the values for this property with this arbitrary. And in this case, this means with integer values from 0 to words length -1. Okay, if we rerun this now with ProTI, we would expect that ProTI doesn't find a bug anymore because we fixed the bug. And that was the case. ProTI ran 100 times our program, which took roughly 30 seconds. Again, we can double check if we introduce the bug again. So I remove the -1, whether ProTI still finds the bug. And this is the case. So with this inline specification, we actually only narrowed down the generator to the behavior of the cloud resource, of the random integer. We didn't overfit. So far, I showed you how you can test this program with ProTI, how it finds the bug, and how we can also test precisely by narrowing down generators if the used generator plugin should be too wide or too imprecise in a certain case. Another aspect that may also need narrowing in specific cases are the oracles. So the type-based oracle we use here also only checks input configuration against types. So for example, the content input property of the bucket object is of type string, And therefore, ProTI checks whether values provided here are strings. But they can be any strings. However, maybe in this specific program, you want to ensure that the content provided is never empty. And you can also do this, again, by narrowing the oracle in this case with ProTI's inline specification syntax. And to do that, we want to say that this value that we provide here is not empty. And we do so by saying ps.expect, and then we wrap this value to, and in this to, we provide a predicate function that implements the check we want to have. And in this case, this could be a simple lambda or fat arrow function that checks that the length of the provided string is greater 0. Again, what we added here in this line doesn't change the behavior of the program when deploying it with Pulumi. However, during ProTI's test executions, every time this bucket object is created, ProTI checks that this oracle, narrowed oracle, is satisfied. So as we always draw values from this array, and this array doesn't have empty strings, we would expect that if we run now ProTI, no bug is found. And again, it took roughly 30 seconds. We tested the program 100 times and no bug could be found, as expected. Now let's introduce a bug. Let's add, for example, the empty string to the array that may lead potentially to situations where content is empty. If we now rerun ProTI, we would expect it to find the bug. And that's the case. ProTI found an error. And if we look into the first error message, we see there was an error found by an ad hoc specification. And the specification was expected the empty string, that was the value received, to satisfy this predicate. So this is how you can use inline specifications also to narrow down oracles in order to introduce application-specific checks. I hope this little demonstration could give you a little insight into how to test Pulumi deployments with ProTI and how to narrow down the generic oracles and generators we have with application-specific properties. If you're interested or have questions, please feel free to contact us. I'm Daniel Sokolowski from the programming group, and you find our contacts on our website, programminggroup.com.